you guys did a good job so far in chapter 11. It's supposed to be a big jump for you guys. All of a sudden you go to series. It takes a while to adjust, but it seems like you guys did a good job to adjusting. And I'm very proud of you guys. Now, we have talked about all those tests, and then now we want to put them all together to think about what are the strategy for testing series. Like, if you look at a series, if you want to know if convergent or divergent, what are the strategy? Okay, so put them all together today. First of all, the easiest the test that you use for series is the test for divergent, which is the end-to-end test, because it's easy to see if the end-to-end go to 0 or not, right? Okay. What does the test for divergence say? If the end-to-end doesn't go to 0, okay, if it's not, then what can we say about the series? The series diverges. Yeah. Okay. Good. Okay. So if not, then what happens is the series diverges. And that's why the name called test for divergence. Okay. So if the end-to-end doesn't go to 0, the series diverge. Okay. Which kind of makes sense, because if it doesn't go to 0, you keep on adding something it doesn't go to 0, and it's going to change, right? As the chain go on, the sum is going to change significantly. Okay. Now, what happened here is, what about if yes? If the end-to-end go to 0, do we have a conclusion for this? If the trend go to 0, if the end-to-end go to 0, can we conclude the series converge or diverge? I think Daniela actually sent out a couple cartoon, very funny picture about that. If the trend go to 0, and the series is going to be and then it was okay. Let me look at Daniela's what's the Daniela's comment? You didn't read her comment, okay? That you fall into the trap, okay? If the trend goes to 0, the series converge. That was the trap. That was the common error student make. Okay. Yeah. So if the trend goes to 0, we have no conclusion. Okay. So you still need to use other tests. Okay. If yes, no conclusion. Okay.
Oh, you're not a clown, you're the whole circus.
Oh, yes, yeah, she remember. And then there's another one. Oh, I like it. Okay, you're not the clown in the whole circuit. Okay, it's good. Okay, so no conclusion, and then you still need other. So need to use other tests. Okay, other tests to do it. Okay. All right, very good. Okay. I think I would like to welcome you guys. If you find anything interesting, like the comment, like, can you post on Ponto? It's related to the material. If you find some, that will increase the participation grade. Yeah.
I just stumble upon.
If you just stumble upon, okay. Do a little bit search on it. Okay. Okay. So this is the test for divergence, or called the end-to-end test. Okay. If it doesn't go to 0, the series diverge. If it go to 0, no conclusion. So you still need to use other tests. Okay. Another one, number 2, is the EC series. Okay. What are the EC series? Geometric series, P series, right? Okay. So what's the general form for geometric series? A to the either n minus 1 power or n plus 1 power or n power. Okay. Okay, so this is a geometric series. The R here is the common ratio. What does it say? When will geometric series converge? If and only if what? Yes, you got it. Good job. Okay, so it converges if and only if the absolute value of R is less than 1, right? Okay, good job. Okay, very nice. Well, you gotta remember. You guys did a good job. You survived 110B. Okay,
X five yet?
almost. This is almost the end. Okay. 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 What about P series? What's the general form? One. Good job. Good job. Okay. When will P series converge? If and only if P greater than 1, right? Okay. Okay, good job. Okay. And also for geometric series, you can actually find the exact sum. Okay. So the exact sum is equal to what? Do you guys remember? Okay. And that A over there is the first term. Yeah, you got it. So I would just say first term because sometimes you say, well, which one is A? You know, it's the first term over 1 minus R. Yes, you got it. Good job. 1 minus the common ratio R. All right. Next one, we talk about telescoping series. Okay. This is an example of a telescoping series. So the way that we write that is, we can try to write that as the difference using, how do you decompose this into the difference of these two? Partial fraction decomposition. Yeah, you got it. Good job. Okay. So from here to this. Okay. All right. And after that, you can try to find, what do? You can try to find Sn, right? The n partial sum. Okay. Then you have A1 plus all the way to An. And then you have those. Okay. And then you see if they cancel, right? So you have this, subtracting this, cancel, etc. Right? And then after you find the Sn, and you will let n go to infinity. Okay, and then see, is it a finite number? Okay, so if it's a finite number, then that's the sum for the series. If it's not a finite number, then the series diverges. Okay, all right. That's for the telescoping series. Okay, what about other series? For other series, like this, a lot of time is going to comparing to the two easy series. So what are the two easy series? Geometric and P series, these two. Okay, so you're going to compare with them. So if they are similar to, yes, it's my phone. But anyway, okay, if it's similar to the geometric series or P series, okay, say P series, and also you have to have positive chain. Okay, it has positive chain over here. Then what kind of tests? Okay, let me give you an example. For example, I have this series, like this series over here. Okay. Well, you think this one here is similar to which series? Okay, so Gloria says 1 over 2 to the n. Yes, 1 over 2 to the n. And for this 3 there, you can think about this 3 here as a constant multiple. You can put it in front, right? Put it in front. Okay, so 3 over that. 3 times that, okay? Now, this series here is what kind of series? Geometric. Yes, very good. That's the geometric series. Very good. So that is, this is the geometric series. Okay. What is R? r equal to 1/2, right? Good. Then what kind of test you're going to use? If it's similar to a geometric series or p-series, what kind of test? Comparison test. Yeah. So we're going to use the comparison test to do it. Okay. So we use comparison test for this. Okay. You can compare them. Compare this one with this one. Okay. To compare them. Because both of them has positive turn, right? Positive turn, positive, positive. Okay. You want to use a comparison test. Okay. There are two comparison tests, right? Can you tell me what are the two comparison tests? One is what's the first one? Direct comparison test. Okay, let's call this CT, okay? CT. Direct comparison test. And what's the other one? Limit comparison test. Okay, so we have two. What is the direct comparison test? Okay, I'm going to put it actually under here so that you can compare them side by side. Okay, so in case you forget. Okay, so the direct comparison test, and this one here is limit comparison test. Okay, how does it work? Okay, now first of all, both of them. Okay, let me just take it away first. To use the comparison test, what's the requirement on the turn first? Can the turn be negative? No, they has to be what? Positive turn, right? So remember not the airplane, right? So this, oh, so this one here is always above, okay? And the other one is always below. And it has to be above this x-axis. So they have to be both positive, okay? Positive, positive, in order to use the comparison test, okay? Okay, now I'm going to compare these two, okay? So like this. So both of them have to be positive. For the direct comparison test, how does it work? So just direct comparing them, right? If suppose a bigger series converge, what can we say about the smaller series? Converges, okay? So if, what else we can say? If the smaller series diverge, what can I say about the bigger series? It diverges. Okay. Notice the relation only go this way. Okay, it doesn't go the other way. All right. So that was a direct comparison test. So over here, I think it's important to show that one is above the other for some add-on, right? Okay. What about the limit comparison test? How does it work? You look at the limit of what? An over Bn. Yeah. Take the limit of this. As n go to infinity, if it's equal to a positive finite number, okay, for example, it goes to 2, then which means in the long run, the an is about twice Bn. Okay, suppose like that. Then what's the conclusion? then either both of them converges or both of them diverge. Remember they come together and die together, right? Okay. So remember if this one died, then the other one died also. Okay. So because in the long run, they're kind of like constant multiple each other, positive multiple each other. So if the series converge, then 2 times that series also converge. Okay. So the series will be either both converge or both diverge. Okay. So they die together or come together. Okay. All right. So that was the difference between the two. Okay. In my opinion, I think the linear comparison test is much easier to use, especially when the A and B are a little bit complicated. When the twins are a little bit complicated, the limit comparison test probably is easier to use. Okay. Because proving this AN less than or equal BN sometimes might not be obvious. Okay. So like that. Okay. So when you have a series that is kind of similar to either a geometric series or P series, you use a comparison test. You can use this comparison test or this comparison test, but I think this one here is more obvious. One. Okay. Okay, the next one, alternating series test. Okay, we call it AST. How does it work? You mean the series has to alternate? Okay, yeah, you got it. So we should have the alternating sign. Yeah. So you have the alternating sign. And then without the alternating sign, then this part here should be always positive. So you have this series over here. What are the 2 conditions to check? Okay, so the 2 conditions to check over here. Okay, number 1. Is what did you say? Divergence? No.
Oh, it's BN.
Yes, it's BN. Yeah. BN what? Go to 0 as n go to infinity? Yeah.
So that's the or equal to.
Okay. Jafar. Ryan said you beat me this time. Okay. All right. Okay. So BN plus 1 less than or equal to BN. Okay. Ultimately, okay. It doesn't have to be all the time. Ultimately. Okay. Then what happened? Yeah, then it converges. Then the series gonna converges. Right? Okay. So you check the 2 conditions, right? So now I'm gonna ask you, what happens if the first one doesn't check? The first one doesn't diverges. Okay, good. So if the first one even doesn't go to doesn't check, okay, so here this one over here, if not, then the series diverge by what test? By test for divergence. Yeah, you got it. Good job. Okay. Now you gotta remember everything. Test for divergence. Test for divergence. Oh, or we call the end-to-end test, right? So when the first one is not satisfied, then we can go ahead and say the series diverge, but it's using the end-to-end test or test for divergence. Okay. Good job. What does it say? Oh, actually, when do we use the ratio test? What kind of pattern? Do you remember what kind of pattern remind you to use the ratio test? When this one here involve factorial, okay, the factorial and factorial. Inside this factorial could be n or n plus 1, etc. Okay, like that. Then you think about use the ratio test. Okay, what else here? When it involve a number to the n power or n to the some power, okay, then we use the ratio test. Okay. How does it work?
X plus one, n plus one.
Yeah, you look at the ratio, right? You look at the absolute value of the ratio. Yeah, don't forget the absolute value. Okay. As n go to infinity, there's 3 cases. If the limit here is, the first one is what? Less than 1. Okay. The next one, greater than 1, or maybe the limit is infinity, right? Then what can we say about a series? Diverges. Very good. Okay. And if it's 1, no conclusion. Yes, you got it. And if no conclusion, what should we do?
No.
Use other tests. Okay. All right, very good. Okay. So from here, there's a weak mark I want to make. Okay, do not use ratio test on P series. Okay, do not use ratio tests on series similar to P series. So if it's kind of similar to P series, so what do we mean similar to P series? Okay, let me give you an example. Like this one, n squared over n to the 5th plus 1. This one here is not a P series, right? However, it's similar to P series because you look at this over this, right? So it is similar to which P series? N squared over square root of n to the 5th, right? So which is equal to 1 over square root of n. So it's kind of similar to that. Okay. So you don't want to use ratio test on a series like this. Okay, do not use that. Okay, next one. How about root test? When do I know which one is the pattern that would suggest that you use root test right away? Yes, you got it. So it was to the n power like this. Then you want to use the root test right away, right? And how does a root test work? You take the n root of absolute value of an. Yes, you got it. Okay. And as n goes to infinity, there are also 3 cases. The first one, less than 1. And then what happened? Not just converges, it converges absolutely, right? Okay. Greater than 1, it diverges. Equal to 1, no conclusion. Okay, good job. And then you use other tests. All right. And then finally, that was one test we kind of always try to avoid, but sometimes it's good to use it. Okay, it's called the integral test. Do you guys remember integral test? Okay. All right. So I have this series here, an, okay, and go from say 1 to infinity. And what do we do? First, yeah, we replace n with x. that was the relating function. Okay, you check the relating function. Relating function, say f. So how do you get this f? You just replace the n over here by x. Okay, so the n over here is going to replace by x. Okay, to get the relating function. Okay, so what happened to this relating function? What are the three conditions this has to satisfy? Yes, positive. You got it. Positive. Okay. What else? Continuous. Good job. Okay. And decreasing. Yes, you got it. Okay. And this one here just need to be ultimately. Then eventually, it's going to be positive and decreasing. Okay. On 1 to infinity. Okay. And if this happens, well, actually, I think the most difficult part here is sometimes is how to prove that it is decreasing. How do you prove that it's decreasing? Yeah, we try to show that the duality is negative, right? So the duality is negative, or you can use algebra like Jaffa preferred, right? Okay, all right. So, and I think Alejandro asked me, what does it mean ultimately? Okay, and just try to explain this as a picture. Okay, so here is the graph over here of a function, first increase and then decrease. Okay, now decreasing ultimately, it just means that from some index on, then this part here is always decreased. It doesn't matter what happened in the past, okay? What happened over here. So as long as it's good after a while, then it's called, it is decreasing ultimately, this one, okay? Okay, so, so if we can show that this one here is decreasing ultimately, then things is going to work. Okay, and then also when you use the integral test, the integral is supposed to be not too hard to find, okay? The integral, let's say from 1 to infinity, if this integral here converge, then what can we say about the series? Also converges. They converge together, right? If this one here diverge, then the other one will also diverges. Okay, so go both ways. Okay, so that was the integral test. Okay, now maybe we just briefly do this. Just tell me what test, okay? Just looking at this. Can you tell me which test you use for this one? The first one? Remember the easiest one is the n-chain test, right? Okay. So you look at the AN, right? You look at the AN, and the AN over here is n minus 1 over 2m plus 1. As n go to infinity, what does it go to? Go to 1/2, which is not 0. By the n-chain test, this one, the series here converge or diverge. Yeah, this series over here diverges. Okay, good. All right, and the second one, just tell me which test. Comparison test, because this is kind of like square root of n to the third, right? Down here is this. So you want to compare comparison test, okay? Compare with which one? So comparison test. Compare with which series you think? you take the dominating term, so square root of NQ over 3NQ. You just compare with that one, okay? The comparison test. All right. And then you can finish it, but at least you know which test to use. Okay. Next one. Am I going fast? Too fast? Okay. Okay, this one. Which test you think you're gonna use? Yeah, you guys are good at it. Okay. Alternating series test because of alternating sign, right? And then this part here is always positive, right? Okay, good. Good job. All right, the next one. Ratio test, you agree? What made you think about the ratio test? Yeah, because of this factorial, right? Involve factorial, right? And also a number to the n power, right? Okay, so this one here, ratio test. Okay, good job. Next one. Comparison test. Oh, nice. So compare with which one? Yeah. So it's 1 over 3 to the n. Yeah, so 1 over 3 to the n. That's the dominating terms, right? Yeah, it's this one over this one. Okay, good job. Okay. Next one. Huh? Someone say root test. Yes, you got it. Okay. I think this one here is going to work very well with the root test. Why? Because remember when this one to the n power, right? Because what happens when you take this n root of this absolute value of this? That's equal to, what is it equal to? How about we just write it in this form, right? So this is n over e to the n square, right? And then raised to the n power is the same as raised to the 1 over n, right? The n root is just 1 over n, right? You agree? Right? Okay. So this one over here is going to be n to the 1 over n on top. And then down here, e to the n square to the 1 over n. Okay. Let's think about this. N square and then later on raise to the 1 over n power. What do you do with the power over here? This 2. You multiply it, right? So this is going to be e to the n square times 1 over n. This is e to the what power? N power. Yes, very good. So this one here, we want to use the root test. Okay, good. The next one. There's no next one? Okay. All right, that's it. Okay, thank you guys for coming. Okay, you guys did a good job.